do a quick review of what we saw this week. So questions 33 to 38. So this week we start graphing exponential functions with shifting. Now here, let me think of this as y is equal to 2 times 1/2 to the x. Let me think of it that way. Let me ignore that minus 1 at the very end for us to begin with. Now here, 2 times 1/2 to the x. My base is 1/2, so I expect the function to be going down. I think of an initial value of x, and then I'm going to multiply by 1/2 if I go in the positive values. Or I can multiply by by 2 if I go to the negative values. So let me think of that. Let me do a chart. When x equals 0, y is 2. Right? That's always that number by itself at the very, very beginning. When x equals 0, y is 2. If I think of positive values of x, 1, 2, 3, 4, positive values of x, I have to multiply the value of y, have to multiply by the base, which in this case is 1/2. Now, 2 times 1/2 is simple, right? 2 times 1/2 is just 1. But then times 1/2 times 1/2 times 1/2, I don't want to deal with halves. Instead, I'm going to go on the negative values of x. So let me think -1, -2, -3. Now, because I'm going backwards, let me think of the reciprocal of 1/2. Right? Reciprocals basically flip the fraction. The reciprocal 1/2 is 2. So for me to come out with the next number, let me multiply by 2. So I start with 2. So I'm gonna have 4, 8, 16, right? Each time I multiply by 2. Now, I will consider this -1 at the very end now. So I'm looking at the function y is equal to 2 times 1/2 x minus 1. All right, the -1 at the very end, basically what that says is on the y values, subtract 1. So let me make a table here. My x values, let me leave them alone. So -3, -2, -1, 0. On my y values, let me subtract 1. So that gives me 15, 7, 3, 1. And then let me plot this points in. -3, 15. That is right here. Then I have -2, 7. -1, 3. And then 0, 1. My graph is going down. And in this case, it is not going to approach 0. It is going to approach -1. Let's take a look at question number 34. To begin with, let me just think of y is equal to 4 times 2x. Let me just look at it that way. I'm looking at y is equal to 4 times 2 to the x. I create a table of x and y values. My x values, I'm going to start at 0, and I'm going to go the positive values. So 0, 1, 2, 3. My first value, my y value, is going to be a 4. For me to come up with the next y value, I have to multiply by the base, which in this case is 2. So times 2. So 4 times 2 gives me 8, 16, 32. Now let me think of the whole function. Y is equal to 4 times 2 to the x plus 2. All right, the plus 2 at the very end basically says on my X and my Y table, I'm going to add 2 to Y. So leave the X's alone. So my X values are going to be 0, 1, 2, 3. My Y values, remember I have to add 2. So my Y values are going to be 6, 10, 18, 34. Okay, so let's see. My first point is 0, 6, 1, 10, 2, 18. Now 334, I cannot graph this. And this function, it looks like it's going up. It is not going to approach 0 this time. It's going to approach -2 on the left, I mean +2 on the left side. So it should look like that. Notice how it is not approaching 0 on the left side. It's not approaching 0. It is approaching +2. All right, let's take a look at number 35. Let me think of the function y equals 3 times 2 to the x. I know in there it says x minus 1, but I'm just thinking of the x. I'm ignoring the -1 for right now. Let me create a table of x's and y's. My x values are going to be 0, 1, 2, 3. For my y values, my first number is 3. For me to come up with the next number, I have to multiply by 2. So it's going to give me 6, 12, 24. Right, each time I multiply by 2. Now let me think of the function now. Let me think of the whole function. Y equals 3 times 2 to the x minus 1. All right, so that means that on the x values, I'm going to add 1. All right, well, the x values is opposite of what we see. I know it says x minus 1, so I'm going to add 1 to my x values. So let me make my table here. Y values, leave them alone. So 3, 6, 12. 24 is not going to fit. So just the y values, leave them alone. On the x values, add 1 to them. So it's going to be 1, 2, 3. We still have this other point. It's not going to fit, but I'm going to put it in there, 424. Okay, so my points here are 1, 3. Let me zoom in here. 2, 6, 3, 12. The other one, 424, doesn't fit on my graph, so I'm just going to leave it like that. And on the left side, this thing is approaching 0. All right, let's take a look at question number 36. Looking at function y equals 1/2 times 1/2 to the x. I'm going to create x and y values. So I'm going to start 0, -1, -2, -3. Okay, 0, when x equals 0, y equals 1/2. That's this number right here. I chose negative values of x because I'm going to multiply by the reciprocal. I don't want to deal with fractions. All right, the reciprocal 1/2 is 2. So let me multiply by 2. 1/2 times 2 is 2 halves, better known as 1. And then times 2, and then times 2. Now let me think of the function y equals 1/2 times 1/2 x minus 2. That means on the x values, I'm going to add 2, my x values. So leave the y values alone. So 4, 2, 1, 1/2. And my x values are going to be -1, 0, 1, and 2. All right, -1 forward, it's, let me graph that one. 0, 2, 1, 1, and 2, 1/2. Graph my points. There you go. Keep in mind on my graphs, I'm going by ones. On your graphs, you're going to be going by two. So be careful on that. Now, 37, 38, our domain and range. I know yesterday I said that domain are the possible x values and range are the possible y values. So for my domain, I'm looking at x, the square root of x. The square root can be positive or 0. The smallest value of x I can think of is 0, right? In order for this to be true, the smallest possible value of x I can think of is 0, because I cannot deal with square root of negatives. So I'm going to say x is greater or equal to 0. Now for my y value, let's see, 2 over 3 times 0, because I'm going to make that square root 0. So 2 over 3 times 0 minus 4. And 2 over 3 times 0 is 0. 0 minus 4 is -4. So y is greater or equal to -4. Now here, number 38, domain are my possible x values and range are my possible y values. All right, so x, have the cube root of x. Cube root, I can deal with positives, I can deal with negatives. So x could be any number, but at this point, we only know real numbers. So I'm going to say all real numbers. Now my range, what's the possible y value that we can get? Because I can deal with negative x's, the cube root of a negative number will give me a very, very small number, right? A negative number. There's no limitation on this one. So for range, it's going to be all real numbers as well. And you do have to type that, all real numbers. Notice I capitalize the A. So when you type it, capitalize A as well.